My name's Pete. I work for Microsoft's Threat Intelligence Center. And throughout my career, I've used threat hunting to help answer that question. Anyone who's done threat hunting before will be able to tell you that it's complicated. You've got to combine data, expertise, a platform, some process, and ideally some level of automation. What we're going to do today, over the next 15, 20 minutes, is use Azure Sentinel to conduct a hunt and use its capabilities to bring together all of the different elements we need for a hunt. Everyone does hunting slightly differently, and every hunt itself will be slightly different. What you find determines where you go and what processes you implement. But broadly, every hunt follows these processes. We have to start by defining what we're hunting for, which forms our hunting hypothesis. We then need to understand the landscape we're hunting in, which, as threat hunters, is our data. We then need to go plan and execute that hunt. If we find something, respond to it. Even if we don't find anything, we want to set up monitoring or some sort of capability to be alerted to activity in future. And as with any good business process, we want to continually feedback and improve based on the output of our hunt. So for the purpose of our hunt today, this is going to be our hypothesis. We want to find compromised credentials that are being used by malicious actors to access our infrastructure. Now, this is a very common attack vector we see people attempting, and it's the main reason why we encourage people to enable MFA. Coming up with these hypotheses can come from a number of places. Previous experience and data is a great one. If you haven't got that yourself, I would strongly recommend using the security community. Blogs, conferences, social media, they're all great sources of ideas for coming up with your own hypothesis. Now we know what we're going to hunt, we need to work out where to hunt it. Every good hunter will have a map. And as a threat hunter, your map might look a bit something like this. This shows us what data we have available, what are the common elements within that data, and how do they appear. So what column names might these common objects appear under in each of these tables? This map will help guide you as you conduct your hunt, helping show you where to go, where to move to next, where to stay away from. Now, unfortunately today, we're operating in an environment where we don't know what data we have. So we're going to start by helping to build our map. So to build our map, we need to get an understanding of our bearings. We can do that quite simply using 3 KQL, or Kusto Query Language, commands, great timing, within the Sentinel log view. The first of which is going to be the search operator. Now, what search does allows me to look across all of the data in all of my tables for a key element. In this case, we're looking for the word sign. The reason we're doing that is because every log is different. We're looking for sign-in data, but how do I know if it's going to be sign-in as 2 words, sign-in as 1 word, maybe hyphenated? Unfortunately, in security, we don't have a common schema for these things, so we need to cast a wide net. Running this shows me quite quickly and easily that there's obviously one table that we want to focus on. But that table still has a lot of rich data in it, and we ideally need to narrow it down into elements within that one table. That's where the next 2 commands come in. Get schema, which shows us the schema of that table, and sample, which takes n random elements from that table so we can look at them. schema shows us each of the column names and the expected data type, which is useful in helping highlight some columns of interest. But how do we know about the quality of the data? How do we know about the completeness? How do we know what some of these actually are? Like category, what does that even mean? We might have one called ID. Well, what ID is that? Is it a GUID? Is it a UPN? We're not really sure. That's why we need to use sample. From here, we can then look at the data in detail and help highlight areas that are going to be useful. So again, here we can see user principal name is going to be much more useful probably than user ID, because that's something we can much more easily understand. Now, this might seem like a very basic step to take, but we've gone here from all of our data in Sentinel, which is potentially petabytes, down to a few columns in a single table. If we don't do this as the foundation of our hunt, any more complex query we try and run later is going to get lost in the noise of all the data we're searching across, or at the very least is going to be a lot less efficient when querying the data. However, this still isn't the end of our scoping down of data sets. With each of these, we've been looking at 30 days worth of data. Now, in an average enterprise organization, 30 days of sign-in logs is a lot of logs. We still need to bring it down into a smaller time window. And there's a number of ways we can do that. This query here is simply summarizing the number of logon attempts we've seen and grouping it by 1-hour buckets. That's what the bin command is doing. Running that shows us not particularly intuitive data, time buckets and counts. But when we put it into a visual view, it becomes a lot easier to see where there might be indicators that are worth looking at. And actually, the ML capabilities in Sentinel have already flagged up this as a particular data point of interest. The other feature that we have that is really useful for the time element is time series decomposition. So using the series decompose command in KQL, what we can do is build a baseline or a seasonal representation of a data set and look at how our data is deviating from that. Classic curse of the live demo. Here we go. Apologies about this. So, what I was trying to show you with this, what this graph shows in the green line is the baseline of that activity over time, and the blue line is the current data set we're looking at. As you can see, we have a number of these spikes away from the baseline that help us identify some anomalies. Now, I haven't had to be a data scientist to be able to run this query. Using KQL and the series decompose, it's taken me a few lines of querying to produce this. This is really kind of powerful capability, especially when you're working with extremely large data sets. Now that we have a time and a data set to look at, we can start doing the more complicated and the more interesting elements of our hunt. So one of the other great features of the KQL language that we're using in Sentinel is its ability to do more than just collect, return, and display data. We can also use it to perform functions and calculations with our data. So our original hypothesis was looking for potentially compromised credentials. One of the ways that we can look at suspicious logons is looking at the location of that logon. Now, we could pull up the location of each one of those and look through, but that's probably not going to help us identify anything that stands out. Instead, what we're going to do is use KQL to calculate the distance of a logon location from another using the haveAssign formula. But how do we identify the point we want to measure from? Well, again, using KQL, what we can do is work out the most common logon location for our organization over the past, say, 30 days. That will likely give us our head office, or at least the main location where our staff are based. We can then look for logons that are a significant distance away from that. It's not going to say that a logon a long way away is definitely suspicious or malicious, but it certainly narrows down our pool of suspicious logons to start looking at in more detail. I'm not going to run through every element of this query here, but we have shared this on the Azure Sentinel GitHub, so if you want to see what we're doing and how this is built, go there and check this out. Now, the results of this show we have a user who's logged on in a number of locations. Washington, Seattle is very close to where most of our users log in. Makes sense. It's where our headquarters are. Some of the others are a bit further away. Particularly things like Moscow might stand out to me as something that's a bit suspicious. Maybe it's not a location of one of our offices or not a country we normally operate in. Now, what I want to do at this point is record this finding. I might want to go on and run future queries and dig a bit more, but I want to be able to come back to this. I can do that by saving it as a hunting bookmark. What this allows me to do is to preserve this finding with some comments and map it to various entities. So I can say, log on location, say this. And I can tag it with a location hunt, maybe. Now, documentation during a threat hunt is really important. You'll likely go down a lot of dead ends as you progress through, and you need to be able to work out what you found, what was interesting, what was useful, and what can be discarded. Similarly, if you need to kick off instant response or engage other parts of your business, their first question is going to be, why are we doing this? If you don't have a document trail, that's going to be hard. And you don't want to be creating that document trail at the end. You want to be doing it as you go. And hunting bookmarks are a really good way of helping achieve that. Once we've saved our hunting bookmarks, we can view them in the hunting pane of Sentinel. So I can see the ones we've saved here, as well as the ones maybe my other colleagues have saved. And we also have the ability to investigate these graphically now. So we can see the key entities from those, the log that I marked as a bookmark. And by right-clicking, I can pivot to other bookmarks perhaps someone else has saved, or alerts, or other data elements. The other advantage of using this graphical interface as opposed to the log interface is you can bring junior members into the team to contribute to threat hunting. The barrier to entry on using this interface is a lot less than having to learn the KQL language before you begin. So in reality, we would continue our hunt in probably a number of different locations after this. But what we're going to do is fast forward through that and say that we've dealt with this user account, we've finished the response process, and we now want to set ourselves up for the next step. Now, ideally, what we want to do is keep looking for suspicious logons and logons from strange locations. Now, we could take that query that we had before, save it, and run it on a regular basis. There's quite a few steps involved doing that in the log view. However, the other part of the hunting view in Sentinel is the ability to save hunting queries. Now, these are queries that you probably don't want as alerts. They're probably going to be too noisy. But they are ones that you would want to run on a regular basis. By saving them in here, we can use the Run All Queries feature to run multiple hunting queries at once and get a summary of the results. This allows us to see which queries might have interesting results. Maybe too many or none can be excluded, and we can just focus on the ones that have 3 or 4. What we can also do is favorite these queries to give us a filtered set. And this is also a great place for kind of field testing detection queries. Maybe you have a query, but you're worried about the false positive rate. Deploy it in hunting queries, run it every day for a few weeks, see what sort of results you're getting, and then you can make the call about whether you want to promote that up to a full analytic. The other thing I want to touch on briefly is notebooks. So notebooks in Sentinel are built upon Azure Notebooks, which provide a Jupyter Notebook experience in the web. So Jupyter Notebooks are an interactive browser-based code environment where you can query data, visualize it, manipulate it how you like. Through Sentinel, you've got one click through to Azure Notebooks, and you've also got a bunch of pre-built hunting notebooks that we've built and released for you to go play with. Now, I'm not going to touch on this in detail. My colleague Ian and one of our MVPs, Martin, are doing a session on threat hunting just with notebooks tomorrow. So if you're interested, make sure you check that one out. So in the course of about 15 minutes, we've gone from having an idea about what to hunt, through to understanding our data, through to conveniently finding something suspicious that may or may not be because it was a demo, to documenting what we found, and to putting in place something to help us in the future. And we've done all of that within the single interface. Now, that's a pretty nice experience for threat hunting. It's maybe not perfect for every situation. There are still going to be edge cases and scenarios where you're going to want to go outside that. But again, that's where notebooks come in. So a few things to consider and take away. The first is the community. It's a really strong community, the security one. Use it, contribute to it. It makes us all better. So specifically, I would recommend checking out some of Microsoft's community elements. We have a number of GitHub repos around Sentinel, the Azure Sentinel blog, Twitter accounts of my team, people like Microsoft Security Intelligence. They can be a great source of ideas and tips that can help. Secondly, don't just limit yourself to looking at raw logs. Data's great, but it's really, really boring. Use visualizations, use the features of Sentinel to help narrow down what you're looking at. Make it a bit more interesting. Don't forget to document as you go. The one time you forget to document stuff is the one time you really need to document stuff. So do it every time. Don't forget about those notebooks. And I guess most importantly, don't think of hunting as a one-time thing. It should be a pretty much continuous process. Now, not every organization is going to be able to do continuous hunting, but you can make it part of your regular schedule. And if you can encourage members of teams that maybe aren't your best security analysts or aren't your best threat hunters to help and contribute ideas, you'll get a much richer experience. Now, if you want to know more about Sentinel, there's a bunch of sessions this week. Check them out, either the ones coming up live or on demand. We're also in the showcase if you want to come talk to the engineering team or people from my team. And if anyone's got any questions, I think we've got about a minute now to answer them. If not, I will be around here for a few minutes afterwards if anyone wants to ask. Great. Thank you.